So this is the 61st video on Newton's laws of motion. This is a continuation of the 60th video. So in this video also I'll take up a numerical problem on Newton's laws of motion involving the concept of combined equation of motion, constraint theory and pseudo forces. Okay. First I'll draw the diagram of the situation. The diagram is like this. There is a horizontal surface. Here there is a wedge whose mass is 3m. The inclined surface of the wedge makes an angle of theta with the horizontal. Here a pulley is rigidly fixed to the wedge. Here there is a block of mass m which is free to slide over the inclined face of the wedge. Here there is a massless string. Okay, here there is a fixed vertical wall. Here there is a massless pulley attached to this wall. Here there is a string, and then again there is like this. See, like this. Okay. So in the diagram shown, there is no friction anywhere, and the string is massless and inextensible. Okay. And these are the massless pulleys. Let us call these pulleys as P1, this pulley as P2, this pulley as P3, and this pulley as P4. Okay, and there is a single string in the problem. This string is massless and inextensible, and there is no friction between string and pulley in contact anywhere, as I mentioned originally here just now. This is the smooth inclined face of the wedge. This is the smooth horizontal surface. System is released from rest. Question is, find the value of theta so that acceleration of wedge W with respect to ground is maximum. G is maximum. Here G means ground and W means wedge. This wedge is being denoted by W and this block is being denoted by B. Alright, fine. So this is the question, okay. So what we are going to do? First of all, we determine the acceleration of wedge with respect to ground, okay. And then that we have to maximize with respect to theta. To find the value of theta so that A is maximum, we do dA by d theta equal to 0 from the rule of calculus. Alright, fine. So first of all, what we have to do, when the system is released from rest, wedge will have some acceleration A with respect to ground in rightward direction. With respect to wedge, the block will have some downward acceleration B. B is the acceleration of block with respect to wedge. And A is the acceleration of wedge W with respect to ground. Okay. One more thing, string is massless and there is no friction between string and pulley in contact anywhere. So tension at all points of the string is same. T equal to C. T say. T is the tension at all points of the string. Okay. Now first what I do, I write down the Newton's second law equation of this block with respect to wedge down the incline. For that first I draw the free body of this block with respect to wedge. See, this is the block. Okay. What are the forces on this block? mg, T, normal force which the wedge incline exerts on the block. Now we are drawing the free body of block with respect to wedge. Wedge is a translating non-inertial reference frame. So as seen from wedge, a pseudo force will act on the block in leftward direction whose magnitude is ma. Now write down the Newton's second law equation of block with respect to wedge down the incline. Alright, so what will I say? mg sin theta plus ma cos theta minus t is equal to mb. This is the first equation, okay. Now what I'll do, I'll write down the combined equation of motion of wedge plus block in rightward direction. Now if you are new to combined equation of motion, go to the 19th video of Newton's laws of motion. You'll get all the details there. Okay. Now to draw the free body of wedge and block with respect to ground, we have to find all the real external forces of the system wedge plus block. Okay. All the real external forces on the system wedge plus block. So what I'll do now, I'll draw the separate free body of block and wedge with respect to ground, okay? So only real forces will come in the combined equation, as has been stated already in the 19th video. Fine. I draw the free body of M with respect to ground, okay? Here I do the free body of M with respect to wedge. Now I draw the free body of block with respect to ground. So here it is Ng, here it is T, here it is N. Okay, these are the only real forces acting on the block. Now I draw the free body of the wedge. I consider P2 and P4 to be the part of the wedge. Okay. So FBD of wedge I draw with respect to ground frame. Alright. So here we have 3 mg weight. Ground exerts a normal force N1 on the wedge. The block exerts a normal force N on the wedge in accordance with Newton's third law. Now here the string exerts a force T on the wedge here, like this T. This P2, pulley P2 has been taken to be part of the wedge. So on the pulley P2, T and T will act like this. This string which passes over P2 effectively exerts force on P2 at only 2 points effectively. At this point and this point, T in this way, T in this way, which I have shown here. P4 is also part of the wedge. So the string will exert a force P4 at effectively 2 points. At this point like this, and at this point like this. Okay, fine, alright. So these are the various forces acting on the system. Okay. Now while writing down the combined equation of wedge plus block, only external forces will appear, no internal forces. Now see which are the internal forces. N and N, they are the internal forces between the wedge and block. So this will not come in the combined equation, it is gone. Now this T and T, they are also internal forces between the wedge and the block. They will also not come, they are gone. Now what are the only external forces? Mg, 3mg, N1, T, 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 T. These are the only external forces on the system wedge plus block. Alright. Now we are writing down the combined equation in rightward direction. So we have to find the component of all these external forces in this direction. This force, this force, this force will not have any component in that direction because they are right angle. Only these forces will have some component in that direction. So the only external force on the system wedge plus block in this direction is 4T. That is equals to 3ma. It is known that in combined equation all the accelerations have to be written with respect to ground frame. Okay. Plus mass of the block multiplied with acceleration of block with respect to ground in this direction. Acceleration of block with respect to ground in what? This direction. So for that what I do? I write down the name of the term. Now suppose rightward direction is taken to be the x direction. Okay. So what will I write here? X component of acceleration of block with respect to ground. This one, see. X component of acceleration of block B with respect to ground. Okay. So 4T is equal to 3ma. Now ABGX will be written as what? ABG dot I hat. Okay. Now M times ABG will be written as ABW plus AWG from the theory of translating frames. This will be written as ABW AWG dot I hat. Fine, alright. Now I have this one. So here I write it here now. So 4T becomes 3ma plus m times what is ABW? Acceleration of block with respect to wedge, which is nothing but vector B itself, plus AWG, which is nothing but vector A itself, and I hat is a unit vector along x-axis rightward direction. So 4T becomes 3ma n times, from distributive law this becomes B dot I hat plus A dot I hat. 4T is equal to 3ma. What about B dot I hat? B is in this way, I hat is that. This becomes magnitude of B 1 into B into magnitude of I hat 1 into cosine of angle between B and I. B is this way, I is that way, angle will be pi minus theta, interior angle concept. So cos of phi minus theta plus a dot I. A into 1 into cos 0 degree, which is nothing but a itself. So 4t becomes 3ma plus ma 4ma minus mb cos theta. You know from trigonometry that cos pi minus theta is just equal to minus cos theta. This is the second equation. So two equations we have already obtained. Alright. Now I'll write down those two equations here. So first equation was what? mg sin theta plus ma cos theta minus t is equal to mb. This was the first equation. And this is the second equation. 4t is equal to 4ma minus mb cos theta. This is the second equation. Okay. Now see, let us count the number of unknowns. How many unknowns are here? A, B and T. Three unknowns are here. So we need three equations. Two equations we have already written down. Now we'll write down the constant equation which will relate A and B. Now suppose with respect to ground, wedge gets displaced by dx amount in time t to t plus dt. And with respect to wedge, the block gets displaced by dl with respect to wedge in same time interval t to t plus dt. Alright, fine. Now I rub this one. So now, constant equation is a consequence of the fact that length of string is constant. A length of string is constant in all the frames of reference. You can write down the constant equation either in ground frame or any other convenient frame. So here I'll write down the constant equation in the frame of the wedge. Okay. Constraint equation in the frame of wedge. Now what is that basic concept? Sum of total work done by string on all bodies in contact with it adds up to 0. Okay, so this will apply in the frame of wedge. Now see, in the problem there is only one string. This one, like this. This is the only string in the given problem. So this string is connected to which body? This string is connected to wedge at this point, first point. This string exerts a force on pulley P1 at effectively 2 points, this point and this point. Now this string exerts force P2 at effectively 2 points at this point and this point, T like this, T like this. Now this string exerts a force on P3 at effectively 2 points, T like this and T like this. And this string exerts a force on this pulley P4 at effectively 2 points, at this point T like this and this point T like this. And this string exerts a force T on this block T in upward direction. So how many points we have to consider while writing down the work done by the string? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 points we have to consider. So we have to find the work done by T. We have to find the work done by string on all these bodies at each of these 10 points. Add up all of them and equate the sum to 0. Okay. Now since we are writing down the constant equation in the frame of wedge, all the work done has to be taken in wedge frame. So all displacements have to be taken with respect to wedge frame. Alright. Now start from here. At this point T acts on this point on wedge in T in rightward direction, and with respect to wedge this point has 0 displacement because it is a material point of the wedge itself. So T dot displacement for this point in frame of wedge will be T into 0. Okay. Now let us take this pulley P1. Now this string exerts a force on pulley P1 at effectively 2 points. At this point T like this and at this point T like this. Okay. Now while writing down the work done by string on this pulley, we have to consider the displacements of this point, 2 points of pulley with respect to the wedge. Now with respect to ground, these 2 points are fixed, and with respect to ground, this pulley wedge gets displaced by dx rightward. So in the frame of wedge, this pulley P2 will move, this pulley P1 will move left by an amount dx with respect to wedge. So this point of pulley gets displaced by dx towards left, and this point of pulley also gets displaced towards left by dx, and T also act in same direction. So how much is the work done by string on these 2 points? Plus T dx cos 0 degree, which is simply 1, plus T dx cos 0 degree, which is simply 1. Okay. Now let us take the work done by string on this pulley in the frame of wedge. Now in the frame of wedge, these 2 points of pulley are fixed. So work done by string on this pulley in the frame of wedge will be T into 0 plus T into 0. Why 0? Because these 2 points of pulley are at rest with respect to wedge. So T dot displacement of this point of pulley P2 with respect to wedge is 0. So T into 0, T into 0. Okay. Now take this point of P, take the pulley P3. This string exerts a force on P3 at effectively 2 points, this point and this point. So T in this way, T in this way. Now to find the work done by string on pulley P3, we have to find the displacement of these 2 points of pulley P3 with respect to wedge. A wedge is undergoing a displacement dx with respect to ground in T to T plus dt, and P4 doesn't move with respect to ground. So in the frame of wedge, P3 will appear to move leftward by an amount dx. In the frame of wedge, the pulley P3 will appear to move leftward by an amount dx. So this string exerts a force on this pulley at this point in T leftward, and this point gets displaced by dx leftward with respect to wedge. So how much do I write on the work done? T dx cos 0 degree. Okay, this is simply 1. Similarly, at this point also we get the same thing. T dx cos 0 degree. Fine. Now we have to find the work done by string on this pulley P4 in the frame of wedge. Now this string exerts a force on P4 at effectively 2 points, this point and this point. And with respect to wedge, these 2 points are at fixed. So work done by string on this pulley P4 at these 2 points is T into 0 plus T into 0. Alright, fine. Now we are left with only 1 point at this point. Now on this block, T string exerts a force T up the incline, and this block gets displaced by dl with respect to wedge. Work done by string on this block with respect to wedge becomes T dl cos 180 degree, T dot dl. So this becomes T dl cos 180 degree, which is simply minus 1. Now they all add up to 0. Now what we get here? T dx, this T dx cos 0 is 1. So 4T dx minus T dl barabar 0. 4 dx is equal to dl. Okay. This is the constraint relation for displacement. But we are interested in the constraint relation for acceleration. Since in the problem there are no variable angles, since in this given problem there are no variable angles, therefore constraint relation for displacement and acceleration have the same format. So now to find the relation between A and B, we replace dx by A and replace dl by B. So 4A equal to B is the required constraint relation. Okay. This constraint relation we have obtained by setting up the constraint equation in the frame of wedge. If I set up the constraint equation in the ground frame, end result will again be the same. Okay, it's a matter of choice. Fine. So this equation right here, B is just equal to 4A. Fine. Alright. Now what we have to do, we have to find the value of A in terms of theta and then maximize it with respect to theta. Fine. I rub this one, alright. So now what I do, I replace T from this equation. What do you get? T is equal to how much? T is just equal to mg sin theta plus ma cos theta minus mb, and b is what? 4a. Replace b by 4a here. mg sin theta plus ma cos theta minus 4ma. Okay. So this is a substitute in this t I put here, and b I replaced by 4a here also. So 4 times t. Now t becomes what? mg sin theta plus ma cos theta minus 4ma is equal to 4ma plus minus mb cos theta, and b is 4a. So b will write as 4a. 4ma cos theta. Alright, fine. Now you see, in this m is common term, m goes away. This 4 is also a common term, So what does it become? G sin theta plus a cos theta minus 4a is equal to 4 goes away here, a minus a cos theta. Alright. So now simplify this for a, then a becomes how much? G sin theta by, now how much will a become? 4a here, so 5 minus 2 cos theta. See, this is the expression for a if you solve this equation. A becomes G sin theta plus 5 minus 2 cos theta. This is the expression for a. Alright. Now we have to find the value of theta so that a is maximum. So for a to be maximum, I suppose this equation is fully clear. Let me just check it once so that there is no careless mistake. Let me just be doubly assured. Okay. So t is equal to mg sin theta plus ma cos theta minus 4ma. Fine. So this t I put in this equation, 4mg sin theta plus ma cos theta minus 4ma equal to 4ma minus mb cos theta, and b is 4ma cos theta. Very good. Now m goes away, 4 also goes away. So g sin theta plus a cos theta minus 4a is equal to a minus a cos theta. Very good. So a becomes how much? A becomes g sin theta 5 minus 2 cos theta. This is the value of a. Now for a to be maximum, implies dA by d theta is 0 by the rule of calculus. I differentiate it using the quotient rule of calculus and interested only in the numerator part of it. So g comes outside because that is a constant term. So what do we get? 5 minus 2 cos theta whole square, quotient rule of differentiation, into 5 minus 2 cos theta into d by d theta of sin theta, which is simply cos theta, minus sin theta into d by d theta of 5 minus 2 cos theta. D by d theta of 5 becomes 0 constant, minus d by d theta of 2 cos theta, which is simply 2 sin theta, that is 0. Because d by d theta of cos theta is minus sin theta, and 1 minus is there previously also, so minus 2 becomes gone. Okay, fine. I love this one, okay. So what do we get here? This becomes 5 cos theta minus 2 cos square theta minus 2 sin square theta is 0. So 5 cos theta is equal to 2 times cos square theta plus sin square theta. This becomes 1 from trigonometry. 5 cos theta becomes 2. So cos theta becomes 2 by 5. So this is the required answer. So angle theta must be cos inverse 2 by 5. It is therefore the required answer. I suppose it is perfectly clear. Okay. And suppose we also find the value of a max. I substitute this value of cos theta in this equation, then we get the corresponding value of a max. Value of a max is then easily obtained. Fine. I rub this one. So a max will be this. So a max becomes this much. G times sin theta becomes 1 minus cos square theta by 5 minus 2 cos theta. Okay. Now cos theta is 2 by 5. I substitute it here. 1 minus 4 by 25 upon 5 minus 2 into 2 by 5. Okay. So corresponding maximum acceleration of wedge becomes how much? G times root 21. 5 goes away. 5 into 5, 25 minus 4. This becomes G root 21 by 21. It becomes G by root 21, which is therefore the required answer. Okay. So maximum acceleration of wedge with respect to ground becomes G by root 21 when cos theta is equal to 2 by 5. So when cos theta is equal to 2 by 5, then acceleration of wedge with respect to ground will have a maximum magnitude of G by root 21. Okay. So this 61st video on Newton's laws, I have illustrated this problem again. Again, you can see the importance of the constraint theory, how much important it becomes when solving questions of this type. Okay. So this problem I use the constraint theory, I use the combined equation of motion concept, then I use the pseudo force concept for solving the expression of this with respect to wedge. So you go through it carefully. In case you have some doubt, write your doubt in the comment box. I'll clarify it. Okay. One more video I'll set up on Newton's laws of motion. Then I'll pass over to friction. Alright. So I close it here. Fine.